Shubham and friends, more examples on potential energy. I hope all these things are interesting and you are following, right? When I said examples on potential energy, first you be ready with those two or three expressions that we have given. System of two charges, what is the expression of potential energy? Then 3 charges, 4 charges, so on. We said for a system of n charges, we will get nc2 pairs of writing that k, q1, q2 by r, is it not? Based on those simple expressions we are doing, and all these are regular, popular 5 marks questions, of course, for your board examinations, right? Today, I will do it at substitution part, at least you try to do. Let us see the first example. As I do 3-point charges. 3-point charges as in 3 microcoulomb, 2 microcoulomb, both being positive. The third one is minus 4 microcoulomb placed at the corners A, B and C of an equilateral triangle of, of side 10 centimeter. Let us take that. Of side 10 centimeter, I will write it. Find the potential energy of the system. So first, for any of the given data, try to write one simple figure whenever possible. So now let us show this is what is the equilateral triangle A, B, C. We said length same, and let us take this L is equal to 10 centimeter in the example, such that A occupies a charge Q1, B occupies a charge Q2 and C occupies a charge Q3. That is the data. Of course, those magnitudes are now given. Now, potential energy of the system, we have to take all the possible pairs of the charges and what is the distance between those two charges. Taking the algebraic summation is our principle, right? If now I am writing potential energy of the system, since there are 3 charges, how many pairs are possible? If you take 3C2, you will get it as 3 over here, right? So this is K, Q1, Q2 by R12. R12 distance between Q1 and Q2. Similarly, the other terms like Q2, Q3 pair, the distance is R23, and of course you have K, Q3, Q1 pair, therefore this is R31. Now all the substitutions with the sign, as I have told you, potential energy, charge should always be substituted with sign. We know this K is, of course, here you see what is that R12 is equal, R23 is equal to R31 is equal to L, which is going to be 10 centimeter, right? And therefore now I am writing U of the system equal to, this K is 9 into 10 rise 9, a common thing, and R12, R23, R31 all are equal to same, that is what is L, which is 10 rise minus 1, or 10 into 10 rise minus 2, shall I write it? So 10 centimeter, no forget. And also here you see Q1, Q2, Q2, Q3, Q3, Q1, all are given in micro. Therefore here, micro into micro becomes, yes, 10 rise minus 12, that is also a common, therefore I will take 10 rise minus 12 is also common. 10 rise minus 12 is also common. This is what is an important thing in all your board examinations or any other thing. Be good at writing those multiples, submultiples, converting them, and without forgetting substituting them. Now here what is that? Q1, Q2. According to me, what is that Q1? Now if I want to write what is that Q1 here? Yes, Q1 is ABC, they said, right? ABC, this is 2 micro, and what is that? Q2 is 3 micro, that is 3 into 10 rise minus 6, both being positive. Of course, nothing is said, then it is positive charge, and this Q3 is given to be the negative, which is minus 4 into 10 rise minus 6 coulombs. So this is the substitution. Already we have taken the 10 rise minus 4 common, therefore it is Q1, Q2. Q1, Q2 is 6 plus Q3. Next Q2, Q3 is minus 12, yes, plus And what is the Q1, Q3 is also again minus 8. This is minus 8. And therefore final answer you have, of course, this is 20 and this is 6, so minus 14. So this is 14 times 9, all other factors like multiples. Here you see it as, this is 10 raised minus 1, this is 10, this is minus 12, right? Therefore it is 10 raised minus 2. And of course, not to forget the unit, which is the energy, the SI unit, all substitutions. Therefore this is joule, 14, 9 joule. And of course, last but not least, what is that? This all, when you consider, you are getting this as a negative energy. I have told you the potential energy of any system, wherever we come across, it can be either positive or negative. Therefore here it has come as negative, which means that it is a bounded system. So this is one such simple example for your board examinations. 5 marks, easy picks. Now what I do is that, the same example, next time I do it with symbols, taking 4 charges and a kind of quick calculation I would like to do. A small change in the example I made, instead of 3, I will consider it as 4 charges, symmetry or geometry changes and all. And one more time I will tell you, where every example, when we are doing that example, not only that particular solution, the concept that we have to understand. See what happens here, the same case of 3 microcoulomb, 2 microcoulomb and minus 4 microcoulomb, such case is taken, but symmetry is not like a triangle, but I give the same as a square. Supposing it is said that ABCD is a square. ABCD is a square of some side, you take number or symbol, whatever it is, such that here this is a charge Q1, here the charge Q3, and here is the charge Q3, and the question is find the potential energy of the system. Find the potential energy of the system. Then what happens? Here also you get 3 pairs. Q1, Q2, distance is L. Q2, Q3, distance is L. And which is the third pair that you will get? Yes, Q1, Q3, and what is this distance? You will get it as, yes, root 2 times L. Therefore now you will again take the same kind of writing the energy for a particular pair and then taking the algebraic addition. So generally here, 3 charges given, triangle given, therefore that is the model. No, it is not that way. For any of the system, it can be the same. Now you see, here I would like to do one more example, right? This one, if you are clear, now let me take. The next example is again, it can be a board example or sometimes it can be your, CET NEET example also. Let me take that with symbols and show you. Right, so this is what is the system I have taken. Supposing these are the 2 charges Q and Q, and exactly midpoint, I said, exactly midpoint. This total distance between them is R, and this is what is R by 2, R by 2. Here a charge is placed Q. Now the question is that, for what value of capital Q placed at the midpoint on their line joining. Remember here both the extreme charges are like charges and they are of course magnitude also same. They are identical charges and the middle charge is Q. For what value of Q, the potential energy of the system, is ZE or O0 is the question. In this example also what we need to do is that writing the same expressions for potential energy, but this time earlier we found the values, but this time we substitute the given value to be 0 and therefore unknown values we will obtain. Therefore in this case what happens? If I am doing it in a quick manner because of what are the pairs and what is the distance. Therefore now I am writing potential energy of the system is equal to, this is small q, capital Q, one pair which is at a distance of R by 2. This is capital Q, small q, again the same kind of pair and the distance is also same. Therefore here, you want me to write? Okay, I will write. This is what is small q, capital Q, of course K is there, by distance is R by 2. The second one is also K, small q, capital Q by R by 2. And what is the third way that you get? These Q on the extreme charges, one pair you get, which are at distance of R, therefore plus, I will write it as K Q squared by R. Now in this question, this potential energy is said to be 0. Therefore, what is this number? This is 2 times is there already there. So therefore, if this is 4kq by R, you will get plus kq squared, of course capital Q is there, right? By small r. By small r, which will substitution, you will get it as yes, what is that? Q is get cancelled, therefore you will have this Q. Therefore capital Q is equal to minus Q by 4, you got the answer, right? You substitute that, so one Q, small q gone, the other side you will get the sign, change of sign and all. Capital Q is equal to minus Q by 4, then potential energy of the system is ZERO, 0. Got the point? We got the answer. Now let us understand one important point regarding the answer, which is very important. What is the meaning of this capital Q equal to minus Q by 4? These extreme charges are identical. I have taken, if I take these charges as a positive charge, the middle charge is a negative charge. That is unlike here, the negative sign, most of the times when you understand the answer, the important thing is that capital Q and small q are unlike charges. If this small q is positive, capital Q is negative, or vice versa. Q negative, capital Q happens to be the positive. So that is what is the meaning of this negative sign. So potential energy of the system, see in just 5 to 10 minutes you can see you have done 2 to 3 examples on one kind of simple concept. How many different pairs we can write, what is the distance that we identified, what is the substitution. So such a very simple thing we have done. So in our next example, in fact I would like to, I will show you, and I will show you in a quick manner. Hopefully you will do that. You follow that. What is that? I will take 4 charges and 4 charges identical, suppose I said 4 charges identical. Now that because pace, writing and all these things, distances, known geometries, therefore I will do it in quick manner. Try to follow that. Suppose the ABCD, the same kind of symmetry I will take, and each of them occupying identical plus Q, plus Q, plus Q, plus Q, right? All the 4 corners occupied with the same, identical charges, each of small q. I am writing it in symbols, maybe for you it can be a number. Now for this system, what is the potential energy? You tell me, potential energy of the system, how many pairs and what type of charges and what is the distance between them. Now you see Q and Q, one pair, 2 Q and Q, this Q and Q, this Q and Q, and these are the 4 pairs, Q into Q, Q square. What is the distance between them? Supposing if I take A is the side of this square, then Q distance is A, Q distance is A. Therefore you got 4 such pairs where you have K, Q squared by A. This is one term that you get, which consists of potential energy due to 4 charges as taken as 4 pairs. Now what is the other pair that is possible? Look at this Q and Q, diagonally opposite pair. I said the NC2 number of pairs we get. Here the 4 charges are there, therefore 4C2 means 6 pairs that you will get. Already we got these 4 pairs. Symmetry is there, therefore we got, and therefore now we are getting 2 more pairs. What is that? Q diagonal, Q diagonal, therefore it is plus 2 times KQ squared. Again, if A is the side of the square, what is this diagonal becomes, boys? It is root 2 times A. And of course, final answer we have substitution and all, and simplification. Here, whatever common terms, whatever it is, KQ squared by A. And this is here becomes root 2, therefore this is 4 plus root 2. Is that okay? This is root 2 by root 2, therefore it is 4 plus root 2. This is what is the potential energy of the system. If it is other examples other than board, such will be the case where you will make use of those pairs, because when it is the case of CET or NEET, always remember the answer to be got in 60 minutes, definitely questions will look like the same. Questions will look like the same. Now this is one more example. Now, I would like to do one example. Sorry, I want to give you one example as your as a homework. It's not homework. In fact, it is a good feast for you for your day. What is that? Right. Earlier I said two charges identical and another charge capital Q placed exactly at the midpoint. What is the value of that middle charge for which potential energy of the system is 0? Madidiva? Two cases, two charges to Madidiva. Now you do this. As a feast, you can do this. Supposing this is an equilateral triangle A, and all these corners A, B, C occupied with the charges Q, Q and Q. This is the corner C. Identical charges occupying the three corners of an equilateral triangle. This is the centroid, capital G. Now the question is that if I place a charge capital Q at the centroid, the question is for what value of capital Q in terms of small q, because here small q is the given charges, given data, capital Q is the unknown, therefore you will get unknown in terms of known. So this is how most of the times we did our example. And when your teacher said that, because for most of the students the biggest problem is that what is the known and what is the unknown. This identification itself is important, at least for our board examination. Five examples are given, 5 marks, 5 problems are given and asked to do 3 examples. Where most of the students, they keep on crying and crying for all the 1 year, which problem, what problem and all. They are very easy, boys, let me tell you. They are very easy. You will get 5 marks, 5 plus 5, 15 marks. You will get it in 10 minutes, because any of the examples solving, it takes hardly 3 minutes. Because what requires, what is the particular concept, what is the particular expression that you will use, what are the knowns, what are the unknowns. Identifying and doing that small simplification, which is nothing but addition, subtraction, multiplication, division, right? So here for this system, we have to find capital Q in terms of small q, which is the data. For what value of Q, potential energy of the system is 0. See here also. Earlier we said that 4 charges, 4 corners of a square. Therefore, how many pairs you got? 6 pairs you got. Here 4 pairs and here 2 pairs, the charges and distance. Here also, when you have 4 charges, always it is 6 pairs. What type of 6 pairs that you get is the important. The small hint is that Q and Q, distance is A. Q, Q, A. Q, Q, A. How many pairs? 3 identical pairs you got. Where Q, K, Q squared by A you will get. And what is the next one? Capital Q, small q, capital Q, small q, capital Q, small q. And these are again 3 identical pairs where you get the distance between these corner and centroid. Even earlier examples also we have made use. What is the distance? Write that. So here also you will get 3 plus 3 pairs. Here you got 4 plus 2 pairs, 6 pairs. Here also the number is 6, but here it is 3 plus 3 pairs. Write it, equate it to 0. You will get capital Q in terms of small q. Right? So this is what is one set of example I wanted to show you. 3 or 4, or even you can do it with any other number of also. But until this 2020, whenever you look back any of the examination papers, board, CET, NEET, other example, you have always have this 3 charges and 4 charges, not beyond that, right? So this is one particular topic I wanted to tell you. Now, same potential energy but asked in a different manner, right? Let us do those examples. Now again I need a board, so I will write few more examples. There also let us improvise one particular example. There we will get 3 to 4 examples. Now one solution yavag madidru kuda remember it should be equal to 5 examples or sometimes 10 examples. because our data again, what are the changes that is possible? Ee tara change adare enagutte, idonde change adare enagutte, ee eradu change adare enagutte. So that is how we cultivate a habit. We habituate ourselves in making more number of examples from a given example. Okay, now let us see in our next board what are the different other examples. Friends, this example is another model you can take for all types of your challenges. This will be a good one. 2 point charges are given, have given numbers, a positive 5 microcoulomb and negative 3 microcoulomb. They are separated by 20 centimeter. Now the question is, find work done in doubling the distance between them. Find work done in doubling the distance between them. So what is happened? You have a system of 2 charges to begin with. Maybe in next example I will say 3 charges or 4 charges. Now what is happening in that particular system? The system is undergoing a change. In this example it is the change of distance. In some other example it can be change of additional charges coming into the system or already existing charges being removed or taken to infinity. These 3 types of changes are possible. Remember, this is a particular concept I am telling you. This concept, this kind of examples. What are the 3 possibilities? Yes, the system undergoes a change. System change yav reeti irubodu, 3 reeti irubodu. Number 1, change of distances, 1 or 2, whatever it is. Next one is the change in the number of charges, additional charges coming into the system, or number 3, charges in the system being removed, that is taken to infinity. 3 tara change kodabodu. In all such examples we will calculate work done by using that work energy principle. What is that work energy principle and what are those things? See here. Now first you understand the given. Always any example, it should be your habit. What is the data and what is the picture that you can imagine. If you get that picture, yes, you got your solution. I am telling you, every time you try to draw a picture. Here what is the case? You have 2 charges, whether these charges are like charges or unlike charges. I have given it as the system of like charges. So these are the 2 charges Q1 and Q2. This is the separation between them, is R1. Now this has changed. In the outer change, the distance has changed. Change can be increase in the distance or decrease in the distance. 20 centimeter double madidare. Okay, doubling means the distance has increased. In some cases, distance may decrease. What is the change? You see. Now the second example, the second figure what I am trying to tell, these are again the charges Q1 and Q2, the same charges, but now the distance has changed and I will change it. I will call this distance as R2. R2 is the new distance. Therefore, what I do is that initially for a distance R1, initially for distance R1, yes, between Q1 and Q2, I will write it as Ui equal to K Q1 Q2 by R1, and then finally for a distance R2, for a distance R2, I will write it as UF, of course for the same case Q1 and Q2, right? UF equal to K, again Q1 Q2 by R2 I will write, right? This is not R1 to R2, this is only R, because earlier it was R1 distance between Q1 and Q2, same charges, distance changed to R2. I repeat this, this distance, the change can be either increase in the distance or decrease in the distance. Now what is that I require? Now by work energy theorem, in fact this is what we did earlier also for about 1.5 hour discussion. work integral W is equal to minus of delta U. You remember this delta is a change in potential energy, minus of delta U. This negative sign is important. This negative sign, if we don't consider, the answers will make a difference, whether it is minus 5 units of work or plus 5 units of work comes the difference. Generally people do miss this negative term, and that is why I would like to give you as one important tool in such examples where you are calculating work as a change of potential energy. Always remember W is equal to, you will write it as UI minus UF. Supposing if you take in this manner, don't use any negative sign now. You can negative sign use madebedi, you will get your answer with right symbols. Positive word, negative word, bandu. This is what is UI minus UF madabeku anta nenebittikoಳ್ಳಿ. Is that okay? Therefore, if I do this W is equal to UI minus UF. What is that? K, Q1, Q2 is a common thing. This is 1 by R1 minus 1 by R2 is the answer. Of course, substitution and answers you will do on your own. Markira. Now let us come to one particular point. To avoid any confusion, finally answer banmele whether it is correct or wrong. I mean, like whether it is positive work or negative work. Doubt in the variable. For that, now you see the data. First, here Q1 and Q2 are given to be unlike charges. Unlike charges, they always attract each other. What is their tendency? They always want to come closer. They tend to move closer to each other. Is it not? Therefore now, attraction irovaga, distance ಜಾಸ್ತಿ ಮಾಡಬೇಕು ಅಂದ್ರೆ it is against force. Work against force is always negative. Therefore, attraction irovaga star ಬಿಟ್ಟು ಬರ್ಕೊಳ್ಳಿ. ಏನಂತ? Attraction irovaga between the charges, attraction irovaga distance ಜಾಸ್ತಿ ಮಾಡಬೇಕು ಅನ್ಕೊಂಡ್ರೆ work negative ಆಗುತ್ತೆ. Supposing attractive ಇರೋವಾಗ ಡಿಸ್ಟೆನ್ಸ್ ಕಡಿಮೆ ಮಾಡಬೇಕು ಅನ್ಕೊಂಡ್ರೆ ಫೀಲ್ಡ್ ಕೆಲಸ ಮಾಡಿಬಿಡುತ್ತೆ. ಎಕ್ಸ್ಟರ್ನಲಿ ನಾವು ಮಾಡಬೇಕಾಗಿಲ್ಲ. Therefore, it is work done by the force ಆಗುತ್ತೆ. ನಮ್ಗೆ ಏನು ಬರುತ್ತೆ? ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ ಅನ್ನೋದು ಪಾಯಿಂಟ್, ರೈಟ್? ಸೊ ಈ ತರ ಸ್ಟಾರ್ ಮಾರ್ಕ್ ಹಾಕೊಂಡು ಬರ್ಕೊಡಿ. ಅನ್ಲೈಕ್ ಚಾರ್ಜಸ್, attraction ಇರೋವಾಗ ಟು ಇನ್ಕ್ರೀಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ವರ್ಕ್ ನೆಗೆಟಿವ್, ಟು ಡಿಕ್ರೀಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ವರ್ಕ್ ಪಾಸಿಟಿವ್ ಬಂದ್ಬಿಡುತ್ತೆ ಅನ್ನೋದು ಬಿಯಾಂಡ್ ಇಂದ ನಿಮ್ಗೆ ಡೌಟ್ ಬರೋದಿಲ್ಲ. Already have told you use this UI minus UF ಮಾಡಬೇಡಿ, ಇನ್ನು ಯಾವುದೋ ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. Similarly, now another star mark ಕೊಟ್ಟು ನೀವೇ ಬರ್ಕೊಳ್ಳಿ. If it is the system of unlike charges, so like Q1, Q2 ಎರಡು like charges ಇವೆ ಅಂದ್ರೆ there exists repulsive. Repulsive ಇರುವಾಗ ದೂರ ಮಾಡಬೇಕಂದ್ರೆ ಫೀಲ್ಡ್ ವರ್ಕ್ ಮಾಡಿಬಿಡುತ್ತೆ. Therefore, repulsion ಇರುವಾಗ ದೂರ ಜಾಸ್ತಿ ಆಗಬೇಕಂದ್ರೆ it is positive work. ದೂರ ಕಡಿಮೆ ಮಾಡ್ಕೋಬೇಕು ಅನ್ಕೊಳ್ಳುವಾಗ ನೆಗೆಟಿವ್ ವರ್ಕ್ ಬರುತ್ತೆ. And that is why we have started our discussion of understanding the potential energies with more than 1 hour discussion with respect to our first year concept, right? So itara madkonbiಟ್ಟು ಈ example ಅಲ್ಲಿ solve ಮಾಡೋಣ. So in this example, charges separation change, therefore what is the work done? Of course, final answer is in ಬರೋದು negative. Substitute with the right SI units. And the multiples don't forget. ಇವಾಗ ಏನು ಬರುತ್ತೆ ಅಂದರೆ 9 times 10 by 9 ಇದೆ. Q1, Q2 ಅಂದರೆ ಎಷ್ಟು ಬರ್ತಾ ಇದೆ? 5 into 3 15 ಬರ್ತಾ ಇದೆ. This is where ಈ 15 ಬರೆಯುವಾಗ ಏನು ಮಾಡಬೇಕಪ್ಪ ಇಲ್ಲಿ ಮೈನಸ್ ಬರಬೇಕು. This is what is minus 15 into 10 by minus 12 because 10 by minus 6 into minus 6. ಆಮೇಲೆ this is 1 by R1 minus 1 by R2. Of course, 10 by minus 2 is the ಕೆಳಗಡೆ centimeter law as it is every time we are doing. Therefore, this is 1 by 20 minus 1 by 40. So, final answer in game bರುತ್ತೆ negative because this is 1 by 20 greater than 1 by 40 ಆಗುತ್ತೆ. ತುಂಬಾ ಜನ ಏನು ಮಾಡ್ತಾರೆ ಅಂದರೆ 1 by 20 minus 1 by 40 ಕೂಡ 1 by 20 ಬರೀತಾರೆ, ಬರಲ್ಲ. This is 1 by 40 ಆಗುತ್ತೆ, is it? 1 by 20 minus 1 by 40 is 1 by 40 ಬರುತ್ತೆ, ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ. Finally is negative. And that is why ಈ ತರ ಬರ್ಕೊಡಿ. And ಬರೆಯುವಾಗ don't forget substitution of these charges is along with their sign. ಅವಾಗ ನಿಮಗೆ ಫೈನಲ್ ಆನ್ಸರ್ ಅಲ್ಲಿ ಯಾವುದೇ ಪ್ರಾಬ್ಲಮ್ ಬರಲ್ಲ. ಒಂದು ವೇಳೆ ಕನ್ಫ್ಯೂಷನ್ ಇದ್ರೆ ಅದಕ್ಕೂ we have given the concept. When is work positive, when is work negative. So now system of charges are given and asked some changes are made and asked to find the work done. Now one more example. In this example, I would like to show another kind of the change in the system of the charges. Right? What is that? See, such a simple thing. You will get lot of interest because the teacher is supplying you with many tools. ಯಾವ ತರ ಥಿಂಕ್ ಮಾಡಬೇಕು, ಯಾವ ಟರ್ಮ್ ಕಾಣಿಸಿದಾಗ, ಯಾವ ವರ್ಡ್ ಕಾಣಿಸಿದಾಗ ನಾವು ಏನು ಮಾತಾಡಬೇಕು, ನಾವು ಯಾವ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಯೂಸ್ ಮಾಡಬೇಕು. This is all the help given by the teacher. Now in this example, I would like to show you. This is yes, an equilateral triangle. I said this is an equilateral triangle. I will use the symbols A. Equilateral triangle ande. And final answer could you all try to write it in numbers only. A, B, C, the same way, 3 coordinates, and they occupy the charges. They occupy the charges. Numbers could go, symbols could go on the edini. Therefore, I am writing it in terms of symbols. You make the numbers barkondu substitute markodi, right? Q1, Q2, Q3 are the 3 charges. Now the question is that. Okay, let me do at least for this sake. I will do. This is 1 microcoulomb, and this one is -3 microcoulomb, and this one is some positive. I will say 7 microcoulomb. This is the system of charges. Now the question is that in the given system of charges. In the given system of charges, I am telling you, find the work done. Find the work done. Change earlier it was a change in distance, right? Distance I am changing it another way. Find the work done in moving, in displacing. I said 1 microcoulomb to infinity. Work done in moving 1 microcoulomb to infinity. So this is the question. So that is what I said. What is that is happening, or what is that is given as a picturesque way. If you understand, this is what has happened. Initially, these are the 3 charges: Q1, Q2, Q3. This is the system. Earlier there was a change in distance here. Now this has changed into a system of only 2 charges, right? Because now Q1, which I call as 1 microcoulomb, is taken to infinity. Our system our charge is equal. Therefore, I will write it as Q1 and Q2. A system of 3 charges, we have changed it into a system of 2 charges. System of charges, yav tara change barbekadru kudanu we need to do work. And of course, that work will be either positive or negative depending upon that nature of the charges. The same way, here what we do is that I, initially what is that energy of the system, which is K, Q1, Q2 by A plus K, Q2, Q3 by A plus K, Q3, Q1 by A. For the 3 charges, 3 pairs here. What is that? 9 into 10 raised 9 common. A is also given. Suppose I take again this as some 10 centimeters. Supposing this is 10 raised minus 1 or 10 into 10 raised minus 2. This is common. And what is Q1, Q2 all given in micros. Micro. Therefore again 10 raised minus 12 is also common. This is common. Therefore now what is that? 10 raised minus 12. So with sign what is that? 1 into minus 3. Therefore this is minus 3 plus minus 3 into 7 minus 21 plus 7 into 1 7. Therefore this is totally expected 10 raised minus 1 10 minus minus 2 there. Therefore this is 9 into 10 rise minus 2 birthday, and all these things you see here 24 and 7, 24 and 7 and 17 birthday. This is minus birthday here. This is yes, and these many joules that you write. This is what is UI. UI, and what is UF? Now UF is simply K. This Q1 alla, that is Q2 is Q3 unquoted. UF is equal to K. Q2, Q3 by A, because there is only now two charges. There are only now two charges, K, Q and Q2 by A. Therefore, this is 9 into 10 rise 9 by 10 into 10 rise minus 2. And what is that? Q1, Q2, this is 10 rise minus 12 is there. Q2, Q3, you will get it as 21. This you will get it as 21. Of course, friends, minus 21. Minus 21. So, this is what is the final answer. 9 ones and 9 twos, 18 times 10 as minus 2, therefore it is minus 1.89, and all these things you will do. Okay, this is what is UF. Now what is your answer? You will calculate UI minus UF mod BD. You got your answer. So there you will not get any kind of confusion with respect to sign. Okay. UI ಮಾಡಿದೀವಿ, UF ಮಾಡಿದೀವಿ. Substitution is the most important point. The sign is very important. The calculation part sign should be carried into the examination. Like this. Supposing ಇದೇ example ನಾನು ಸ್ವಲ್ಪ change ಮಾಡಿದೆ ಅನ್ಕೊಳ್ಳಿ. Supposing if I change it and somebody call it as a neat example or somebody calls it some other example. Naming is not important. See now ಮಾಡಿದ್ದು 1, 2, 3, 4 stepwise. Now, same example, what I would like to improvise this time is, right, equilateral triangle, and here I say the side of the triangle is once again A. All the three corners occupying the charges identical, supposing I said small q and small q. Three identical charges occupying the corners ABC of the equilateral triangle, ABC of side A. This is all the data, the problem that is given. Now the question is that what is the work done? In bringing, very meaning, find the work done. Find work done in bringing another 2q charge, from infinity to the centroid of the triangle. Find the work done in bringing a charge 2q. Let me tell you, this is also some positive charge. Nothing is given means positive charge. If I have to say it as a negative charge, with sign it will come here also plus, and this is also a positive charge. Find the work done bringing a charge of 2q from infinity to this centroid G is the question. And the same question, instead of bringing this 2q, you can also say it as find the work done in bringing this charge q, one of the charges at corner C, Q to centroid. C in G or displace body. It is not the fourth charge that is coming into the system. Already the charge which is present in the system, this is what is small q. This small q, of course I will write it as one more example. This is find the work done in bringing. This is another 2q charge from infinity to centroid. The next example you will do the same data that the charge Q at C, the charge Q at C is displaced. Of course, whenever I said displaced mode, it is always with uniform velocity, understood. Actually, it should be given meticulously, but take it for granted if nothing is said. This charge Q at C is displaced to centroid G of the triangle. Mean the same triangle. So this is again a question. We can go on improvising such any of the questions. See here for this question I have made it as AB, and C part also I can do. First you do these AB parts for this, right? For this you do AB parts of this, and we'll continue more examples in our next board, right? Yeah, friends, this example and the solution, when I am giving the solution, each and every statement that I make, everything you underline, because one more example of course, but this example is again a big concept, a big concept. More examples can be created from this concept. So that is why, look at this concept, data, solution, each and every statement. I said a particle, a chargeable particle of mass m and charge q is fired, that is projected with a velocity v. I am using all the symbols. In the maybe examples we will be given numbers. Yadinda fired particle from infinity. What is meant by infinity? Infinity means there is no interaction between the two charges, therefore there is no question of any energy concept like potential energy. So fixed charge, it is fired with a velocity v from infinity towards a fixed charge, fixed light charge, capital Q. This is one more charge and this is fixed. There are now two charges, one the small q which is projected, and I call this as projectile, and this is the fixed charge which is light. If this is positive, this is also positive. This is an important point to be taken. Therefore this is where the example, both the charges are like charges, therefore there is a repulsion. Find the closest distance of approach of the particle. This is English, we will understand what is the physics of that. Closest approach. And what is the closest approach and all. See this example here, again as I have told you, a situation to be always drawn as a figure. You got 50 to 60% of your answer. This is the charge capital Q, which I call, earlier I told I will call this as a target because this is a fixed one. Now this is the charge, and here is the reference infinity. Infinity and yes, this charge affects other charges up to this boundary. Beyond that it won't. Therefore now here I have taken a charge q, which I will call it as a projectile. This is called as projectile. See, these are all the terminology that we have used in our first PU. Collisions, one dimension collision, two dimension collision. Remember, this is what is the terminology. This is the fixed one, the target, and this is the one projectile. And this is fired with some velocity v, with some initial velocity v. Now remember, here these are like charges, therefore I will write it as plus, and this one is also plus or minus. Then, because of its velocity, it has this kinetic energy, mass is also there, right? So because of the kinetic energy, it starts moving, but due to the electrostatic repulsion, the velocity gradually decreases for that projectile. So velocity and hence energy of the projectile gradually decreases. Which energy? Kinetic energy. So velocity and kinetic energy of the projectile gradually decreases. Illi bandi enagide. I will now call this some specific point which is capital P. Capital P liberosity. Now I am now writing projectile stops. Stopping point of projectile. Projectile ಇಲ್ಲಿ ಬಂದು stop ಆಗಿಬಿಡುತ್ತೆ because of electrostatic repulsion. In fact, ಈ ಎರಡು ಸ್ಟೇಟ್ಮೆಂಟ್ if you can write on your own, and this is important, ಯಾರೋ ಹೇಳ್ತಾರೆ ಸುಮ್ಮನೆ ಕಾಪಿ ಮಾಡೋದು, because it takes you nowhere. ಇಷ್ಟು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ಮೇಲೆ you need to write those two statements. What is that? Small q is the projectile when fired from infinity due to electrostatic repulsion, its velocity gradually decreases and hence kinetic energy also decreases such that when it reaches the point P, its kinetic energy becomes zero. That is, it stops. Stop agidalla. Adike this, if you call this as O, OP is now I am calling it as, of course it is a stopping distance is different. See, illinda no bandu illi bandide. That is what is the other case. It is not starting distance. It is distance of approach. Therefore now OP is now called distance of closest approach. Closest approach. ಅತ್ಯಂತ ಸಮೀಪಕ್ಕೆ ಬಂದಿದೆ, ಇಷ್ಟಕ್ಕನ್ನ ಸಮೀಪ ಬರಕ್ಕೆ ಅದಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಆಸ್ ಕ್ಲೋಸೆಸ್ಟ್ distance of closest approach. Distance of closest approach. Now we want this OP. Supposing if I call this as some distance D, OP is equal to, if I call it as a D, is what is called as the distance of closest approach. Now one simple expression derive ಮಾಡೋಣ. And all this expression treatment is based on principle of conservation of energy. Principle of conservation of energy without any exceptions, of course. Therefore, now I am initially at infinity. Initially at infinity. Yes, what are the different energies and what is the total energy? Since infinity what is that? I is equal to 0, no potential energy, whereas there is velocity and mass, so the mechanical energy, kinetic energy is there. Therefore now I am writing kinetic energy is half mv squared. Therefore total initial energy I am writing. So total energy is equal to simply half mv squared. Next time I am writing finally at point P, which is the closest approach. At P, what happens? Stop agide. Therefore, velocity is equal to 0. Velocity 0 implies kinetic energy equal to 0. And what is the potential energy? Now here we will write UF. So potential energy is equal to, yes, our expression of potential energy, two particles, capital Q, small q, by what is the distance between them? I have shown it as OP, which is nothing but D. Therefore here what is the total energy? So total energy is nothing but capital KQ by small d. Now conservation of energy, right? Conservation of energy. You get your expression. Therefore now I am writing conservation of energy. Conservation of energy gives, yes, this capital K, capital Q, small q by D is equal to half mv square. Therefore now I am writing the final expression for D, right? So the D will be nothing but, right, this is of course 1 by 4 epsilon, everything is there, K, this is 2 is also there, 2 capital Q, small q by 2 times K capital Q small q by mv square is the distance of closest approach. This is what is B. If numbers are given, you will substitute. Of course, this is 9 into 10 by 9. All other magnitudes are given, you will write. The most important point is that now looking and understanding this concept of distance approach, and this is what is our regular habit, it must be. Again, what is LHS, what is RHS, what are the constant terms and how the dependency is there. There are the changes, because this B, D depends upon, yes, the magnitude of the target, the magnitude of charge of the target, also it depends upon the charge of the projectile, both are directly proportional. It is depending upon the mass and also the square of the velocity of the projection, and both are inversely related. That is why now here, what is the biggest example maybe for your CET NET, where I will write it again. Number of times I have told you, if I say D1 by D2, any of them can be changed. 1, 2, 3, 4 terms are there. Any one term change, 2, 3, right? We can have. Therefore, D1 by D2 is equal to what you write? Capital Q1 by capital Q2, small q1 by small q2, m2 upon m1, inverse relation, and velocity also you will see inverse and square is there, v2 upon v1 whole square. Like when get it after that, you please understand this expression. Different types of examples, number of other examples with changes, numericals, percentages, and all can be done using that concept, right? So these were some of the examples I wanted to tell you based on potential energy, right? Hope you will do all of them, and for any doubts and for any additional assignments, call your teacher. Have a good day, stay safe and stay at home. Good day, friends.